Greetings from the Hermitage and welcome to this presentation on calculating the distance between 2 points that lie either on a horizontal or vertical line. And in this presentation we'll introduce something called the absolute value. One of my favorite pastimes is riding my motorcycle, and one of my favorite trips is from my home in La Luz to Ruidoso. And typically what happens when I leave my Hermitage here in La Luz, I'll set the trip meter to 0. And whenever I arrive in Ruidoso, I'll check the trip meter to see how far I've gone, and that'll typically say about 46 miles. At that point, I'll take a little break, maybe have a strawberry milkshake or whatever else appeals to me at that time. And then when I get back on my motorcycle to come home, I'll reset the trip meter to 0. Then when I get back to La Luz, I check the trip meter again and see that it's 46 miles from Ruidoso to La Luz. And the point here is that the distance is the same positive number regardless of which direction I traveled. My motorcycle keeps track of that quite easily by counting each mile in each direction. Now the problem in math arrives whenever we calculate the distance between 2 points on a horizontal or vertical line, and the problem arises because distance between 2 points is a subtraction. But we always want the distance, we'll specify the distance as being a positive number. Regardless of what we initially calculate, we want our distance number to be a positive number. Let's see how we handle that by looking at this horizontal line. Remember, it doesn't make any difference whether it's horizontal or vertical, but I just happen to have a number line that's horizontal. And let's say that we pick 2 points at random and we want to know the distance between them. So here I've chosen 2 and 8 on the number line, and I can calculate the distance or I can just count it. So here's 2, and then every time I move, here's 1, 2, 3, 4, 5, 6. That's like me going from La Luz to Ruidoso. And here I am at Ruidoso and I want to go home. I count back 1, 2, 3, 4, 5, 6. So the distance is exactly the same regardless of which direction I counted. But like I said, distance is a subtraction calculation. So to get 6, I can do this. I can say 8 subtract 2 equals 6, and that's my positive number. But I can say to go from 8 to 2, I have to subtract 6. So I could say 8 minus 6 equals 2. Now here's my distance, but here I had a negative number. And the way we handle that is to define something called the absolute value. So I will define the distance as the absolute value of some value x2 subtract x1, where these vertical lines represent the absolute value. And the absolute value says whatever number in here, right, once I take the absolute value, the result is positive. For example, if I say the absolute value of -5 equals, it just equals a +5. And if I have the absolute value of +5, that also gives me +5. The point is that the absolute value always returns a positive number. So let's define distance as the absolute value of some number x2 subtract some number x1. That will always give us a positive number. Now let's look at this example where we have 3 and -5. We can count from -5 up. That's 1, 2, 3, 4, 5, 6, 7, 8. So we know our distance is 8 by counting. Let's see what the calculation looks like. So we know that 8 equals, and I'm going to pick at random -5. And now I need to subtract. There's a subtraction sign. -3. But we know that distance has to be a positive number. So this is going to be 8 equals the absolute value of -8. 8 equals 8. Now something really interesting happens if I choose 3 and -5 in a different order. I know the distance is 8. And let's say that I choose 3 first and then minus a -5. I mean, this is a subtraction. This is 3 subtract -5. I can rewrite 8 as 3 plus 5. And this equals 3 subtract a -5. Now I have 2 terms on the left-hand side of the equal sign, and I have 2 terms on the right-hand side, and there's something called one-to-one correspondence. So if I know that those 3's are the same, then this +5 has to equal subtract a -5. And this is one of the ways that we get that a negative number equals a positive number. So we have -5 equals +5. I could have put the absolute value signs in here. Wasn't really necessary this time because I got a positive number to begin with. But remember, the definition is the distance equals the absolute value of the difference between 2 points. If we're talking about a vertical line or a horizontal line. Let's look at one more problem. We've defined the distance as the absolute value of x2 minus x1. And I can write these two numbers in either way that I choose. So distance equals, I'll say, should be a vertical line. Let me erase that mess. The absolute value of -7 subtract a -2. That's going to be the absolute value of -7. And we just saw that a double negative is a positive. So we get distance equals the absolute value of -5. The absolute value sign just says whatever is inside the absolute value bars, change it to a positive or leave it as a positive. And we can see by counting, there's 1, 2, 3, 4, 5 spaces between -7 and -2. Let's look at it like this. Once again, distance equals the absolute value of x2 subtract x1. This time, I'll start with -2, bring down the subtraction sign, put that negative number in parentheses. Distance equals the absolute value of -2. And we know that a double negative equals a positive. This equals the absolute value of +5. Distance equals +5. The point is that it doesn't make any difference how you choose x2 and x1, because we will get a positive value because our definition says take the absolute value of the difference between those two numbers. Always, regardless of what you calculate, whether it's negative or positive, in the arithmetic, the distance must be specified as a positive number, regardless of how you choose your two x values or two y values if you're talking about a vertical distance. That just about wraps this one up. And there's only one thing left to say, and that is, that's all, folks. Thanks for watching. Thanks for learning. Be safe. Con cuidado.